Hi friends, we have to find the remainder of 2 power 256 by 17. These kind of remainder problems are very easy once we know the trick. The trick is our very familiar binomial expansion. Now, to understand that binomial expansion, right? What is our binomial expansion? X plus y, let's say, so is raised to the power of n. It is, we can write it as x power n plus nc1 x power n minus 1 into y plus nc2 x power n minus 2 into y square, whatever, up to nc n minus 1 x power n minus 1 into y plus y power n. What is our binomial expansion? Well, each term, it starts with, the first term starts with nc0 and it will go to ncn. nc0 is 1, which is this, and ncn, which is also 1, which is this. The coefficient goes from nc0 to ncn. Right, NC0, NC1, NC2, NC3, 4, n minus 1, n. Right, and x goes from x power n to x power 0. The last term will have x power 0, that is 1. Right, x power 0, y power n. Similarly, y goes from y power 0 to n. Right, y power 0 is 1. Then y power 1, y square, y cube, y4, whatever. Right, so, sorry, here there is a small typo here. It is x power n, x power 1 and y power n minus 1. Right, y power n minus 1. There is this typo. Y power n minus 1. Right, y power n minus 1. Y goes from 1, 2, 3, 4 to n minus 1 to n. X goes from n to 0, y goes from 0 to n. Right. Now, if you see in this entire expansion, in every term is x multiplied by something. In fact, all of these terms except the last term. Last term is y power n. Until then, there is either a x or x square, x cube. The last term will have x, and before that will have x square. Before that, x cube, and finally here x power n. Right. In all these terms, there will be at least one x, and except the last term, which is y power n. Right. That means this entire term is a multiple of x, except all these terms are multiples of x except the last one. So now let us use this trick here. Right, 2 power 256, we can write it as 2 power 4 power 64. 464 is 256. 2 power 4 is 16 power 64. 16 we can write it as 17 minus 1 power 64. This 17 minus 1 is in the form of x plus y whole power n. Right, once we expand everything like this, x is 17 here, right? All the terms will be multiples of 17 except the last one, y power n. What is y power n? Minus 1 whole power 64. Except the last one, everything else is a multiple of 17. Right, so whatever all these terms, when divided by 17, they'll give remainder 0. We are not worried about that. Only thing that we are worried about is minus 1 whole power 64 by 17. Minus 1 raised to the even power. Even power is always plus 1, right? 1 by 74. 1 by 74 means the remainder is actually 1. Right, guys? So, this entire expression, cleverly we have converted this into 17 minus 1 whole power 64 and then used our binomial theorem to understand, to realize, or to use this property that this only the last term will not have a factor of 17, or we can leave a remainder when divided by 17. Rest all are multiples of 17. Right, guys? This is how we converted this kind of thing to this binomial expansion, right? These kind of all remainder problems, most of these problems can be solved like this. Right? It is pretty easy. Right, guys? Thank you.